Hi everyone, welcome to YourPedia. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at YourPedia. Today in this video we are going to solve some 20 very good questions for ISRO from the subject control systems for the post of scientist or engineer, right, for the branch Electronics and Communication Engineering. You all know that ISRO announced its notification for the CBT computer based test, that is ISRO examination for various branches like electronics and mechanical. So YourPedia started a dedicated module for the same. So you can join your hands with YourPedia to accelerate your preparation towards your ISRO examination preparation, right? So let's start into the subject. So in this video I'm going to discuss some 20 very good questions. In that, some 30% of the questions are from previous ISRO paper. Okay, so for various years ISRO questions only. Remaining 70% are similar models or some good concepts of control systems from two topics. I'm not covering all the topics in this video, only two topics, that is transient response or time response analysis. Yeah, time response analysis and stability analysis. Mostly I'm going to cover time response analysis, then partially stability analysis. These two topics I'm going to cover in this video. Let's enter into the video, please. The very first question is related to error. What is saying? A unity feedback system has G of S is equal to K by S into S plus 10. Okay, an open loop transfer function, that is an open loop transfer function is saying. If the damping ratio is 0.5, then what is the value of K? It is not related to steady state error, it is related to damping ratio. You tell me what is the characteristic equation. Characteristic equation is equal to 1 plus G of S is equal to 0. What is that? Characteristic equation is equal to 1 plus K by S into S plus 10 is equal to 0. So from this one, characteristic equation is equal to S square plus 10S plus K, that is equal to S square plus 2 zeta, that is the damping ratio, 2 zeta omega ns plus omega n square is equal to 0. Now you compare, yes, 2 zeta omega n is equal to 10. Yes, let me take a new page. Yeah, let me take a new page here, and there I will solve. Yes, we got 2 zeta omega n is equal to 10, and we got omega n square is equal to k. Yes, we got omega n square is equal to k, right? Now zeta is 0.5. 2 into 0.5 into omega n is equals to 10, then omega n is equals to 10. That implies k is equal to omega n square. K is equal to omega n square. Therefore k is equal to omega n is 10 square, that is k is equal to 100. K is equal to 100. So option is B for Bombay. The option is B. Simple question it is, right? Let's go to the next question, please. The steady state error of a stable type 0 system, unity feedback system for unit step input is, let me write the steady state error formulas. Steady state error for step input is A by 1 plus Kp, where Kp is called as position error constant or step error coefficient. Kp is limit s tends to 0 GSHS. Limit s tends to 0 GSHS. Now this is for step input. ESS is equal to A by KV, where A is the, here in step input, A is the magnitude of the step. If it is unit step, A is equal to 1. If it is step of magnitude 2, A equal to 2. Now here A by KV, where K is the slope of the ramp. This is for ramp input, where KV is equal to limit S tends to 0 S into GSHS. S into GSHS. KV is called as velocity error constant or coefficient, right? Or ramp error constant or coefficient. It is called as ramp input, is also called as velocity input. Now ESS is equal to A by KA A is the coefficient of or A is the slope of the parabolic input at t is equal to 0. Okay, now what is Ka? Ka is called as parabolic error constant, or I can say acceleration error coefficient. Step input is called as position input, ramp input is called as velocity input, parabolic input is called as acceleration input, right? Now Ka is equal to limit s tends to 0 s square into GSHS, s square into GSHS. Observe carefully, he is asking for what input? Step input. Therefore option E, B for Bombay, A by 1 plus Kp, but unit step input where A is the magnitude of the step, which is equals to 1, right? Next question please. What is saying? Third peak overshoot and second undershoot of the step response of the second order underdamped system is, first of all, for any, it may be first peak overshoot or second peak overshoot or third peak overshoot or first undershoot, second undershoot, whatever it is, the formula is MP is equal to MPN, I call e power minus n pi into zeta divided by root of 1 minus zeta square. If you ask me to draw the diagram response with respect to time, so this is A is the input magnitude. Now this is 0. Yes, this is how we get. This is how you get. And this is 1 overshoot. 1 n is equal to 1 is overshoot. N is equal to 2 is first undershoot. N is equal to 3 is a second overshoot. N is equal to 4 is a second undershoot. Very simply, in the next page, let me write. Yes, in the next page, let me write. That is, yes, e power, see, MPN. Let me write here so that it is visible to you, all of you, very clearly. MPN is equal to e power minus n into pi into zeta divided by 1 minus zeta square. N is equal to 1, 2, 4 and so on for overshoots. For what? Overshoots. N is equal to, sorry, 1, 2, 1, 3, 5. I wrote it wrong, just a minute. I wrote it wrong. 1, 3, 5, odd numbers. 1, 3, 5 and so on. Yeah, you can observe here. 1, 3, next 5 are overshoots. 1, 3, 5 odd numbers are overshoots. Then 2, 4, 6 and so on are for undershoots. Undershoots. Now he is literally asking about, yes, third peak overshoot and second undershoot. Third peak overshoot. Yes, first of all, overshoot means this first one, second one, third peak overshoot. Second undershoot, first undershoot, this is second undershoot. Now MP 5 I call e power minus 5 pi into zeta by root 1 minus zeta square. MP 4 is equal to e power minus 4 pi into zeta divided by root of 1 minus zeta square. Observe, 4 and 5 will be the answer. 4 and 5. Option is B for Bombay. Yes, e power minus 4 pi. But no. Here D is the answer, D for Delhi. Why? He is asking third peak overshoot, first place. Third peak overshoot. Third peak overshoot is for n is equal to 5. Second undershoot is asking for n is equal to 4. Option is D for Delhi. So there is a possibility this kind of confusion. He is asking respectively. In the options he is saying respectively means first one is first one, second one is second one. First one is asking third peak overshoot where n is equal to 5, right? N is equal to 5, right? Next, come to the next question please. He is saying the unit step response of a system for the transfer function. He given a transfer function. Yes, unit step response. What is the transfer function? Output by input. Laplace of output by input is the transfer function. Now he is asking C of t. This is C of s. Now tell me what is C of s. C of s is equal to R of s into 1 minus s by 1 plus s. What is R of s? R of s is nothing but yes, a unit step input. R of t is u of t then R of S is 1 by S. R of S is what? 1 by S. Now C of S is equal to 1 minus S by S into S plus 1. 1 minus S by S into S plus 1. But even in terms of time domain, therefore we need to find its time domain answer. Now let's find its partial fractions. This is S, this is S minus 1. Sorry, S plus 1. Put S is equal to 0, you get it as 1 by 1, you get 1. If you put S is equal to 0, S is 0, 0, 1 by 1. Put S is equal to minus 1, put S is equal to minus 1. 1 minus of minus 1 is 2. 2 divided by minus 1, it is minus 2. 1 by S minus 2 by S plus 1. 1 by S minus 2 by S plus 1. Apply inverse Laplace to this, and this corner I am doing. Now C of t is equal to 1 by S inverse Laplace transform is U of t minus 2 into e power minus t into u of t. Yes, if you take u of t common, 1 minus 2 into e power minus t, the whole into u of t. 1 minus 2 into e power minus t, whole into u of t. Option is A. Option is A. Let's go to the next question, please. For a second order system, the damping ratio zeta is 0 less than zeta less than 1. Then the roots of the characteristic polynomial are, yes. Let me discuss about all possible cases. Zeta is equal to 0, system is called as undamped system. Undamped means no damping. Undamped system, its response is purely oscillatory. Its poles are going to be on imaginary axis. Purely imaginary poles it is going to have. Means there is no real part is 0. In fact, we take this one as plus j omega n, this one as minus j omega n. Now second case is 0 less than zeta less than 1. Zeta is greater than 1 but greater than 0 but less than 1. Okay, greater than 0 but less than 1. It is called as underdamped case. Underdamped system. Yes, it is what system? Underdamped system. Then poles are complex conjugates, means in the negative part. Yes, negative side. Yeah, poles are complex conjugate, means their real part is equal, imaginary part is equal but opposite in sign. This is minus j omega d, this is plus j omega d. Conjugates means both are mirror images to each other. This is minus zeta omega n. Poles are complex conjugates. Complex conjugates. Here answer is complex conjugates. Now let's discuss about zeta equal to 1 and greater than 1 also. Just zeta equal to 1 and greater than 1 also let's discuss. Now if zeta is equal to 1, poles are, this is first of all called as critically damped system. This is called as critically damped system. Critically damped system. Poles are real and equal. Yes, poles are real and equal, right? Poles are real and equal. This is minus omega n, sorry. Now zeta is greater than 1, system is called as overdamped system. Overdamped system. System is what? Overdamped system. Yes, poles are real and unequal. Real and unequal. Yes, this is S1 we call, this is S2 we call. This is about all possible systems of a second order system, right? Next question. Given a second order system, what is the characteristic equation given? Given characteristic equation s square minus see, let me write the characteristic equation s square minus 0.75 s plus 0.25 is equal. Just by looking at it, this is an unstable system. Yes, this is an unstable system. Sir, how do you know? There are sign changes in the characteristic equation. This is having plus 1 as the coefficient. This is minus 0.75. This is plus 25. Whenever there is a sign change between the coefficients of the given characteristic equation itself, the system is said to be unstable. Now, overdamped, no, underdamped, nothing, exponentially growing. Exponential growth it is. Why? Because see, an overdamped, unstable system. This is an unstable system. Unstable system response keep on increasing without bounds. Unbounded system it is called as. So, overdamped means no oscillations at all. Underdamped, oscillations are there but will die out. Critical damped, no oscillations at all. Exponentially growing. Yes, exponentially it will grow like this. Means I will draw this way the response will increase. Just let me take this one this way. Yes, exponentially the oscillations are increasing. So option is D for del it is, right? Next question. A transfer function g of s has pole 0 plot. So this and this are previously asked ISRO questions. Okay, as I told you, 30% of the questions are from previous ISRO exam. I'm not marking which question is exactly from ISRO. Knowingly, I'm not marking. Okay, yeah. A transfer function g of s has a pole 0 plot as shown in figure. Okay, fine. Given that the steady state function gain is 2, okay, the transfer function g of s is, first of all, let's write g of s. G of s is equal to, it is having one 0, so k into s plus 1 divided by, it is having two complex poles, so that is s plus 2 plus j1 into s plus 2 minus j1, right? So g of s is equal to k into s plus 1 by s plus 2 whole square plus 1, right? S plus 2 whole square plus 1 if you can simplify it. But he is saying the steady state gain means s tends to infinity. Steady state means t tends to infinity. Steady state means finally, right? The final value of gain is how much he is saying? 2. Means put s is equal to 0 in this, you are going to get put s is equal to 0 in this, right? So first of all, let me simplify it. G of s is equal to k into s plus 1 by s square plus 4s plus 5, right? So if you put s is equal to 0 in this, k by 5, why s is equal to 0? T tends to infinity, steady state value. K by 5 is equal to, you are going to get k by 5. Yes, k by 5 is equal to 2. This is a steady state gain. Put s is equal to 0. Steady state value, final value t tends to infinity, s tends to 0. The initial value t tends to 0, s tends to infinity, right? Steady state means final. Okay, k, why? Because if you put s is equal to 0, k by 5 is equal to 2. That implies k is equals to 10. K is equal to 10. So 10 into s plus 1 by s square plus 4s plus 5. 10 into s plus 1 by s square plus 4s plus 5. Option is C. C for Chennai, right? Next question, please. So this one we already, formulas we know. A unity feedback control system with open loop transfer function is, then the Kp, Kv, Ka is asking. Kp, Kv, Ka is asking. Let's do those things. Solution. Kp is what, ma? Limit s tends to 0, this total function k into s plus 2, okay, divided by s square into s square plus 7s plus 12. Now something by 0 is infinite, na? Yeah, k 0, 2k by 0 is infinite. Next, kv is also limit s tends to 0, s into the same, then also you are going to get infinite. Ka is, yes, Ka some finite value you are going to get other than infinity. Ka is limit s tends to 0, s square is s square only, k into s plus 2 divided by s square into s square plus 7s plus 12, s square gone, limit s tends to 0, you are going to get it as 2k by 12, therefore it is k by 6. Answer is what? K by 6. Infinite, and k by 6. Option is A, right? Next question, please. The transfer function 1 by 2s plus 1 will have, okay, what is the transfer function given? Transfer function is equal to 1 by 2s plus 1. What is its DC gain? DC gain means put s is equal to 0. Put s is equal to 0 in the transfer function. DC gain, okay, okay, put s is equal to 0 in the transfer function, s is equal to 0. What is that? 1 by 2s plus 1 at s is equal to 0 will give you 1. And high frequency gain is asking. What is high frequency gain? S is infinity. High frequency means what? High frequency means what is the highest possible frequency? That implies s is tending towards infinite. Now 1 by, take s common, 1 by s into 1 plus 2 plus 1 by s. Now some 1 by infinite into 2 plus 1 by infinite. 1 by infinite is 0, 1 by infinite is also 0, right? 1 by infinite is 0. Yes, answer is 0. 1 and 0. 1 and 0 please. Yes, option is C for Chennai. DC gain is 1 and high frequency gain is 0. Next, the second order system is given. What is the damping ratio? What is the damping ratio? From this one, first of all, get the characteristic equation. How to get the characteristic equation? Apply Laplace on both sides. 2s square plus 4s plus 8 is equal to, no, let me, into y of s is equal to 8 into x of s. Transfer function is nothing but y of s by x of s. Y of s by x of s, that is 8 divided by 2s square plus 4s plus 8. 4s plus 8. Now compare this one with the standard equation. What is the standard equation? S square plus 2 zeta omega ns plus omega n square. Compare with this one, you get it as omega n is equal to root 8. Yes, omega n square is equal to 8. From this one, omega n is equal to root 8. 2. No, we should not compare directly. We should not compare directly. Why, sir? It is not in the standard form. So take 2 common first of all. S square plus 2s plus 4 is equal to 0. That is equal to s square plus 2 zeta omega ns plus omega n square. So from this one, omega n square is equal to 4. From this one, omega n is equal to 2 we got. Now 2 zeta, we don't know, omega n is 2, that is equal to 2, 2 gone, zeta is equal to 1 by 2, that is 0.5. It is not having any units. Option is D for deadly. Just comparing with the standard equation. That's why I did it fastly. Comparing with the standard, but standard is having coefficient of 1. Therefore, yours also must become coefficient of 1. That's why we taken common 2 and we cancel it, right? Next. For the following, which of the following is a steady state error for a step input applied to a unity feedback system with open loop transfer function? Yeah, what is error formula? Yes, just in the first question or second question we wrote for step input, unit step input, right? Yeah, what is the input given? Steady state error for a step input. Okay, as we did not mention the magnitude of the step, we take it as unit step. If you mention step of magnitude 2, we'll take A is equal to 2. A is 1 by 1 plus Kp. What is Kp, ma? Kp is equal to limit s tends to 0 g of s, that is 10 by 50, that is equal to simply 1 by 5. Now ESS is equal to 1 by 1 plus 1 by 5, that is 5 by 6 simply. Yes, it is 5 divided by 6. How much it is? 5 divided by 6. Yeah, 0.848. Nah? Then how much is left? 2 is left. Yes, 3. 0.833. Option is B for Bombay. ESS is right. Let's go to the next question. Damping ratio of a series RLC circuit is, for series RLC, damping ratio zeta is R by 2 into root of C by L. For parallel RLC, I'll tell you how to remember. Once you remember this one, series, parallel you can easily get. 1 by 2 you keep it as it is. R reciprocal is to R. You replace L with C, C with L. If you remember this, how to remember this one, sir? You are going to get series RLC characteristic equation as s square plus r by l into s plus 1 by l is equal to 0. Compare that one with the s square plus 2 zeta omega n plus omega n square. You get that. That's not a big deal. But how to get parallel? Parallel somewhat derivation is difficult for us. That's why just r 1 by r duals, l c duals, duality. I applied the concept of duality, right? And the damping ratio is not having any units. Right. Next. Consider a system with transfer function g of s is equal to s square plus 6 by k square plus s plus 6. Its damping ratio will be 0.5. Then what will be the value of k? Now tell me what is the characteristic equation, that is k s square plus s plus 6 is equal to 0. Now s square plus s by k plus 6 by k is equal to 0. Now tell me how much is saying zeta is 0.5. Zeta is equal to s by s. This is the zeta, that is equal to 0.5. So how you got this expression? Compare this one with the s square plus 2 zeta omega ns plus omega n square. Compare, then the zeta value you are going to get. So from this one I'll send this one to this side. That implies 1 by k is equal to 2 into 0.5 is 1 into under root of 6 by k. From this one 1 by k square is equal to 6 by k. K gone. That implies k is simply 1 by 6. K is how much? 1 by 6. Option is C for Chennai. Right? Next question please. A system described by the transfer function, then the constraints on alpha and k are, we want that one to be stable, right? See, I am doing this one with the shortcut. Yes, characteristic equation is s cube plus alpha s square plus ks plus 3 is equal to 0. The shortcut for a third order system is, first of all, if you want to apply shortcut, these things must satisfy. That is, all must be positive, means alpha must be greater than 0, k must be greater than 0, and this is must and should required, anyhow, right? And this is 1 and this is 3. For stability, yes, this must be required. And what is the actual condition? Internal product coefficients alpha k must be greater than external product of the coefficients, that is 3. Alpha k must be greater than 3. Just a minute. Alpha into k must be greater than 3, right? Product of these two, alpha k must be greater than 3. See, observe, this is the condition. Internal coefficients product must be greater than external coefficients product, then it is said to be stable. For a third order, it is applicable if and only if all coefficients are positive. Sir, how you got that shortcut? Apply RH criteria, from that we get, right? So look at the options. Option A is not correct. Alpha must be greater than 0, alpha k must be greater than 3. So option is B for Bombay, right? Next question please. A system with a characteristic equation is asking about its stability. Now apply RH criteria. S power 4, S cube, S square, S power 1, S power 0. Right? Then yes, come here. 1. After that 3 you neglect, 6. 1, 3 you neglect, 6. Then 9 you leave, then 12. Then nothing is there, 0. Right? Then with the 3 you start, yes. Then 9 you take, then nothing is there, 0, 0. Right? Now first two rows will be directly filled. You start with S power 4, take it, leave it, take it, leave it, take it, leave it. Next you start with the S cube. Next, take it, leave it, take it, leave it. That's all. Right? Now from here to here, 18 minus 9 is 9. 9 divided by 3. 9 divided by 3 is 3. Now this is 3 minus 3 into 12 minus 0 by 3. This is 12. This is 0. This is 0. Right? This is 9 3s 27. 27 minus 36. 27 minus 36 is minus 9. Minus 9 by 3 means minus 3 it is. Minus 3. Yes. 3 into 9. 27 minus 36. 27 minus 36 is minus 9. Minus 9 by 3 is minus 3. This is 0. This is 0. This is 0. Then you calculate this. This into this minus this into this by this will be, again this is 2. This is plus, this is plus, this is plus, this is minus, and this is plus. There are two sign changes. This is the first sign change and this is the second sign change. There are two sign changes in the first column of Routh array. Right? Yes or not? It is unstable with 2 RHP. Unstable with 2 RHP. 2 right hand side poles. Next question please. A system open loop transfer function is given, okay, if the system is having negative feedback, unity negative feedback, which of the following is true for a system to be stable? Here also I am giving one shortcut, that is suppose you have an open loop transfer function GSHS is equal to K by S into S plus A into S plus B, where A comma B are greater than 0, then the condition for stability is 0 less than K less than AB into A plus B. System is said to be stable. Compare, in place of A you have 2, in place of B you have 4. 0 less than K less than AB is 8, A plus B is 6. That implies 0 less than K less than 48 is the answer. 48 is the answer. Any mistake I committed? 4 into 2, 8. 4 plus 2 is 6. So options are not there. Yes, options are not matching. Yes, but ours is correct only. 0 less than K less than AB into A plus B. AB 2 into 4, 8. A plus B 2 plus 4, 6. 8 into 6, 48. Answer is it is 48, not 24. Please change the option. That's all. Right? This is one of the shortcut. This is one of the shortcut for this is applicable only for this one. Right? So these shortcuts how we got and all we learn in classes. Right? Next question, please. Next question. What is saying? The closed loop transfer function of a control system is given. What is the frequency of the sustained oscillations for marginally stable system? He is asking what is the condition, what is the frequency of the oscillations of the system. Here also again I am using shortcut. What is the characteristic equation? We will get this is S square plus S. See, this is denominator na? Denominator of the transfer function is called as characteristic equation. This is the denominator. S square plus S into S plus 5. S square into S cube plus 5S square S plus S square plus 5S plus K is equal to 0 is the characteristic equation. Now characteristic equation is equal to S cube plus 6S square plus 5S plus K is equal to 0. What is the condition I given previously for stable? If this internal product is greater than this external product, it is stable. If internal product is exactly equal to external product, it is marginally stable. If it is marginally stable, it is oscillating with some frequency. Yes. What is the condition for marginal stability? Yes. 30 is equal to K. That implies K is equal to 30 is needed, then the system is marginally stable or critically stable. Marginally stable or critically stable. Then omega oscillations formula is under root of D by B. How much is D? K. By B is how much? 6. But D is how much? 30. 30 means marginal gain by 6 under root 5 or under root of C by A. What is C? 5 divided by A is how much? 1. Sir, what is this ABCD? Compare this one with this one. Characteristic equation is equal to, I am writing AS cube plus BS square plus CS plus D is equal to 0. Compared with this one, A is 1, B is 6, C is 5, D is K. What is the formula for omega oscillations? Under root of D by B. Yes, sir. This is from under root of D by B. This is from under root of C by A. So anyhow, with both we got same answer. We must get the same answer. Root 5 radians per second. Option is A. Option is A. See. The system is represented by its transfer function has some poles lying on imaginary axis of the S-plane, then the system is marginally stable. If there are poles on imaginary axis without repetition, he did not mention with repetition or without repetition, but we are taking it as without repetition, system is marginally stable. Yes, the system represented by its transfer function, okay, has some poles lying on imaginary axis of the S-plane, the system is marginally stable, right? If he says that poles are repeated on the imaginary axis, system is unstable. Right? Next. So the intersection of asymptotes of root loci of a system with open loop transfer function. Intersection of asymptotes is nothing but centroid sigma A, which is nothing but sum of the poles minus sum of the zeros by number of poles minus number of zeros. Sum of the poles, tell me, pole 0 is one pole, at minus 1 another pole, at minus 3 another pole, minus no zeros divided by 3 minus 0, yes, minus 4 divided by 3, this is minus 1.33, minus 1.33, option is DD for Delhi. D for Delhi, right? Next, root locus starts from open loop poles and ends at open loop zeros. Let me write. See, root locus starts from, yes, root locus diagram starts from open loop poles and ends at open loop zeros. So starts at open loop poles and ends at open loop zeros. Option is A, right? So these are the 20 very good questions from the control systems from the topics time response analysis, stability analysis and root locus, right? All the best. Thank you.